Welcome to this lecture on animal behavior. Today, we are going to explore a fascinating and crucial topic, the importance of communication in the animal kingdom. If you have ever wondered why birds sing, why frogs croak, or how wolves coordinate a hunt, you are in the right place. We will build our understanding from the ground up, looking at what communication really is, why it matters, and the hidden evolutionary economics that drive it. Let us dive in. To appreciate our topic, imagine you are lost in a dense, dark forest. A severe storm is approaching, and you need to find your friends. But you cannot shout, you have no flashlight, and you cannot leave a trail. Your chances of reuniting and surviving are incredibly slim. This exact scenario is what animals would face every single day if they lacked the ability to communicate. Communication is the invisible glue that holds animal societies together. It allows individuals to interact smoothly, avoiding constant physical violence or wandering aimlessly. From a tiny insect finding a mate to a massive elephant warning its herd, sharing information is absolutely vital for survival. Now that we understand why it is necessary, let us define what biological communication actually is. In the scientific study of animal behavior, communication is formally defined as the transfer of information from one animal, the sender, to another, the receiver. This transfer must subsequently alter the receiver's behavior. It is not just about making random noise. The process requires a specially evolved signal, which could be a sound, a chemical scent, a visual display, or even a physical touch. Crucially, this signal must have evolved specifically to convey information, and the resulting response must generally benefit either the sender, the receiver, or both. By altering the receiver's behavior, the sender effectively manipulates its environment to gain an evolutionary advantage. Having defined communication, let us visualize it with this fundamental model. On the left, we have the sender, animal A, who produces a signal. This signal, which could be visual, auditory, or chemical, travels across the environment toward the receiver, animal B, on the right. Notice the jagged line above the signal arrow? This represents environmental noise or interference, which can disrupt the message. If the signal successfully reaches the receiver, it triggers a behavioral response, shown by the curved arrow pointing back to the sender. This response ultimately determines the evolutionary benefit or cost of the interaction. This simple loop is the foundation of all animal communication. With the basic model in mind, let us look at why communication matters so much in the real world. Its importance simply cannot be overstated, as it touches every single aspect of an animal's life cycle. First and foremost, without communication, animals would be completely unable to locate and attract suitable mates. This would quickly lead to the extinction of their species. Beyond reproduction, communication is crucial for survival. It allows animals to resolve intense conflicts over valuable resources like food or territory. Instead of engaging in deadly physical fights, animals use intimidating displays to settle disputes. This strategy saves valuable energy and prevents severe, life-threatening injuries. Beyond individual survival, communication plays another vital role. It is the absolute foundation of all complex social structures. Think about wolves hunting in a coordinated pack, or meerkats standing guard to defend against predators. These cooperative behaviors are entirely dependent on the rapid and accurate exchange of information. Communication also allows animals to work together to raise their offspring, ensuring the next generation survives. In short, communication is the ultimate survival tool. It takes isolated, vulnerable individuals and transforms them into a highly functioning, interacting biological community capable of overcoming immense environmental challenges. Now that we see the immense benefits of communication, we must also consider the risks. To truly understand why animals communicate, biologists look at the evolutionary economics of signaling. Producing a signal, like a loud roar or growing a bright feather display, always requires energy. More importantly, making yourself conspicuous might attract unwanted predators. Therefore, a communication signal will only evolve and persist in a population if the evolutionary benefit outweighs these inherent costs. It is a strict biological accounting system. If the costs become too high, the behavior will be eliminated by natural selection. To analyze this, biologists use a specific mathematical model. This brings us to the mathematical heart of our topic, the cost-benefit fitness equation. The formula is delta W equals B times P minus C. Let us break down what each symbol means. Delta W represents the net change in the sender's evolutionary fitness, which is their ability to survive and reproduce. B stands for the fitness benefit gained if the receiver responds favorably, like mating or backing down. P is the probability, ranging from 0 to 1, that the receiver actually hears the signal and responds. We multiply B and P to get the expected benefit. Finally, C represents the total cost of producing the signal, including calories burned and predator risk. For a signal to evolve, delta W must be positive. If the cost C increases or the probability P drops, delta W becomes negative and the animal will stop communicating. Let us see this formula in action with a concrete example. Imagine a small bird spots an approaching hawk. It must decide whether to give a loud alarm call to warn its flock. We are given that the benefit of saving its relatives, B, is 80 fitness units. The probability that the flock hears the call and hides, P, is 0.75. However, making noise draws the hawk's attention, so the cost, C, is 20 units. We plug these into our equation. First, we multiply the benefit of 80 by the probability of 0.75. This gives an expected benefit of 60 units, accounting for the fact that the signal does not work perfectly every time. Next, we subtract the cost of 20 units. The final answer is a positive 40 units. Because the net fitness is greater than 0, the evolutionary benefits heavily outweigh the risks, and the bird will instinctively make the alarm call. Now let us look at a different scenario. Consider a male frog at a noisy pond at night, deciding whether to croak to attract a female. A successful mating provides a massive benefit, B, of 100 units. But because the pond is noisy, the probability a female hears him, P, is only 0.20. Meanwhile, a bat is hunting overhead, so the cost of revealing his location, C, is 30 units. We substitute these values into our equation. Multiplying the mating benefit of 100 by the low probability of 0.20 yields an expected benefit of just 20 units. We then subtract the predator risk cost of 30 units. The final answer is negative 10 units. Because the result is less than 0, the cost of attracting the deadly bat is simply too high. In this dangerous situation, the frog is better off staying completely silent. The frog example we just solved perfectly illustrates a broader biological truth. Environmental factors directly control when and how animals choose to communicate. In the frog's case, the high background noise of the pond drastically lowered the probability of his signal succeeding. At the same time, the presence of the hunting bat significantly increased the cost of making a sound. Animals are constantly, instinctively evaluating these shifting environmental variables. If the environment changes, their communication strategies must adapt immediately to ensure their net fitness remains positive. This dynamic balancing act is happening all around us in nature every single day. We have covered a lot of ground today, so let us summarize the key takeaways. First, biological communication is not random noise. It is the deliberate transfer of information that alters a receiver's behavior. Second, this process is absolutely essential for survival, allowing animals to find mates, resolve conflicts peacefully, and build complex, cooperative societies. Third, communication is strictly governed by evolutionary economics. An animal will only signal if the expected benefits outweigh the inherent costs and risks, as modeled by our fitness equation. By understanding these principles, you now hold the absolute key to unlocking the mysteries of all social behavior in the animal kingdom. Thank you for joining me in this lecture.